Okay, let's start with the wild idea. What if you could program your farm, like a biological operating system? Today, we're diving deep into something called hybrid natural farming, or HBNF. This isn't just another farming method. It's a system that treats agriculture not as a random collection of inputs, but as a precise code. A code you write to achieve total biological independence. Let's get into it.
This right here, this is the core manifesto. It's a declaration of independence. The whole philosophy is about a massive shift in thinking. You stop renting your fertility from chemical companies, and you start manufacturing your own biological wealth, using things that most people would just call waste.
And here it is, the ultimate goal, the big, powerful promise of this whole system. It completely reframes how we think about pests. You're not fighting them anymore. Instead, you are literally engineering a plant that pests can't even recognize as food. It's not about defense, it's about making the plant metabolically invisible.
So, before we get into all the how-tos, we really need to wrap our heads around the why. Because this isn't just a new set of recipes to follow. Nope, it's a completely different way of seeing the farm itself.
This really gets to the heart of the philosophical shift. On one hand, you have passive decay. You throw some organic stuff in a pile, cross your fingers and hope for the best. But that often just invites putrefaction, what the system calls biodrift. But on the other hand, HBNF demands metabolic precision. Every single action is like a line of code designed to get a specific, predictable result. It is active, it's intentional, and it's all about control.
And all of this precision leads to one thing: biological sovereignty. This means you are officially off the input substitution treadmill. That endless cycle of swapping one purchased product for another? With this, you are the factory. You are the source. You have complete and total control over your own fertility.
Okay, so if the farm is a biological computer, how in the world do you program it? Well, you need a master key. You need a tool that can unlock all the potential that's just sitting there, locked away inside your raw materials. Let's find out what that is.
And here it is. It's called Nuruk. Now, don't think of this as just another ingredient. It's really the foundational technology for the entire system. It's like a dense brick of concentrated digestive power, a fungal complex grown on wheat that is just jam-packed with enzymes. It is the master catalyst.
I love this analogy because it perfectly explains what Nuruk does. It acts as molecular scissors. See, the enzymes in Nuruk don't just sit around and wait for slow, random decay to happen. No way. They get in there and they actively, precisely snip apart complex molecules, making them instantly available for use. It's an incredibly fast and efficient way to pre-digest food for your soil's microbiome.
So here's that crucial process in action. It's called enzymatic hydrolysis. You start with something complex, right? Like the starch in a potato. For microbes, that's locked food. They can't get to it easily. Then, step 2, you add the key, the Nuruk. Its enzymes immediately get to work, unzipping those long, complex starch chains into simple sugars. And just like that, you have immediately available fuel. We're talking rocket fuel for your microbes.
All right, we have our master key. Now we can start writing the foundational code for plant health. We're going to build the engine, starting from the ground up, with the soil itself, and then we'll move to the plant's ability to build its own muscle, protein.
Level 1 is all about rebooting the soil. The main objective here is to create what HBNF calls the soil stomach. You're literally building a thriving digestive system right there on the earth. A biological superhighway of fungal networks that naturally breaks up and decompacts the soil, no tillage required.
And here's the very first line of code we're going to write. It's called One Potato Microbial Solution, or OPMS. And just look at how simple this architecture is. You take a boiled potato, that's your local carbon source, a really key Western adaptation that replaces the rice used in many Asian systems. You add the Nuruk, our enzyme catalyst, to unlock all that starch. A little bit of sea salt for minerals and some water. That's it. This simple ferment is designed to perfectly mimic the sugars that roots exude, and it triggers an absolute explosion of local, beneficial fungi. Now that the soil is waking up, we can move to level 2, building the nitrogen engine. And the objective here is really profound. You're not just feeding the plant nitrogen, you are making sure the plant can fully process that nitrogen into complete proteins. This is the critical step that makes the plant basically inedible to pests.
So, why do pests attack in the first place? Well, this is the core insight. When a plant can't properly metabolize nitrogen, its sap fills up with raw nitrates. This is essentially pest candy. It even gives off an infrared signal that's like a dinner bell for aphids and mites. The solution? a specific trace mineral, molybdenum. It acts as the spark plug for the enzyme that converts those raw nitrates into complete proteins. No more candy, no more pests. Simple as that.
So how do we actually build this engine? It's a two-part system. First, you need the fuel. That's purple gold, a culture of purple non-sulfur bacteria, or PNSB. These incredible microbes take a waste product, like urine, and transform it into pathogen-free, plant-available amino acids. But of course, fuel is useless without the spark plug. And that comes from a simple ferment of Brazil nuts, which just happens to be the planet's densest biological source of molybdenum. You put the fuel and the spark plug together, and you get a complete protein engine.
So once the plant's protein engine is running strong, it starts to generate surplus energy. And now it can move to the upper levels of the pyramid, using all that extra energy to build its defenses. It is time to activate the shield.
Level 3 is all about building physical armor. The plant uses its surplus energy to create lipids. These are fats and oils, and it pushes them to the surface of the leaf. This forms a waxy, waterproof shield, a hydrophobic barrier, that airborne fungal spores like mildew and blight simply cannot get through.
And how do you know if it's actually working? This is the beautifully simple validation test. You just spray the leaf with some water. If the water sheets out and makes the leaf all wet, the shield is weak. But if that water beads up into perfect little spheres, you know the lipid shield is active and doing its job correctly. It's a direct visual confirmation of plant health.
And finally, we reach the top of the pyramid. Level 4, total systemic immunity. With a surplus of energy and a fully active shield, the plant can now manufacture its own complex chemical defenses. We're talking about those aromatic compounds, terpenes, phenols, alkaloids, the things that give plants their unique smells and flavors. Well, they are also powerful enough to neutralize chewing insects and even stop viral threats in their tracks.
So we've walked through the different levels, the specific inputs and ferments, but the real power here is seeing how it all connects, how it works as a single integrated system. So let's zoom out for a second.
This right here is the key takeaway. HBNF is not a collection of recipes to just follow blindly. It's a biological operating system, a BOS. Each ferment, every single input is a specific command. You're not just adding fertilizer, you're issuing a command to the system to execute a precise metabolic function, like finish protein synthesis or build lipid shield.
And this operating system is not really meant for a single user. The community philosophy is summed up in this quote: "Apart, we shall perish." The true resilience of this system really emerges when a whole network of farms starts working together, sharing these ferments, creating a regional microclimate, a sort of microforest, or pests and disease simply cannot get a foothold.
And all of that leaves us with this final thought. HBNF suggests a massive paradigm shift. It asks us to seriously consider that maybe, just maybe, the future of food isn't just about what we grow, but about the biological code we use to grow it. It's a fascinating and incredibly powerful new way to think about our relationship with the land.